So water is a common solvent. Since we are learning about solution and solution stoichiometry, water is a common solvent. Okay, and that you can find, it's important, and you can find on earth, and it's one of the most important. The main thing why it's a common solvent, because you can dissolve many things. Many different substances. Now, water is a polar molecule. Polar molecule, which is unequal distribution of charges. So, water molecule is a polar molecule because unequal distribution. Unequal, I would say, charge distribution. So let's say for oxygen, I'm going to try to draw a water molecule. This is oxygen, okay? And then one hydrogen attached and other hydrogen attached, okay? Now this charge on oxygen is 2 delta minus 1 because it's negative charge oxygen, and this is positive charge. Positive charge. So whenever it's unequal distribution of charges, polarity goes from hydrogen to oxygen, and there is a bond angle between them is 105 degrees, about 105. That's the bond angle. It's a bent shape water molecule, and it is the most common solvent. Okay. Now we are going to talk about nature or the types of component. I would say components in a solution. So we have solute. When we make solution, solute we need it. What is that solute? The substance being dissolved. Substance being dissolved. What is solvent? If we can take a liquid water or major amount, it's called solvent. Major amount, this one you solidify small amount, and most amount, that's a solvent. Now we are going to define electrolyte. What is electrolyte? Okay, so let's start with electrolyte definition. A substance when dissolved in water and produces a solution. And that solution can conduct electricity. That is called electrolyte. It produces electricity. Now in electrolytes there are three types. There are three types of electrolytes. Strong electrolytes, weak electrolytes, and non-electrolytes. So we'll differentiate those electrolytes. How we can differentiate? So for that, let me show you one equipment that usually help us to find the solutions and strong, weak or non-electrolytes. Alright? So I'm trying to draw that. Let's say if we have a bulb, okay, and have two electrodes. Electrodes means it conducts electricity. And that one, okay. Now when this equipment, when we immerse into a solution, let's say these electrodes that conducts electricity, and let's say this is a solution, these are electrodes, electrodes that conduct electricity. And this is a bulb, light bulb. Now let's say if we have, this one is a strong electrolyte. We are making the solution of strong electrolyte in a water, right? And then we dip these electrodes into it. What happened? Those charges, plus minus charges in this solution, they pass through these electrodes. And when they pass through electrodes, what happened? They brighten up the light bulbs, right? Okay, so the light bulb shines brightly when we completely immerse these electrodes in an ionized water or solution. So whenever it shines brightly, that means we can call this electrolyte is a strong electrolyte. Alright, so this is very efficiently, bulb shines brightly, then we can call strong electrolytes. Now let's say these light bulb glows dimly. Let's say if it is glows dimly, then we can call this electrolyte weak electrolyte. And let's say some of the solutions, this bulb will not work at all, then we can call non-electrolyte. Now why is that so? Because in the strong electrolytes, when you drop the solute in water, what happens? It completely dissociates. It completely gives 100% ion in it, right? So that's why it's a strong electrolyte. So I'm going to write those definitions. Strong, weak, and non-electrolytes. So strong is completely ionizing water. And it conducts current. Conducts current. And bulb shines brightly. Now for weak, it's a small degree of ionization. In water. It conducts a small current, or only small current, and its bulb glows dimly. It's dim. And for non-electrolyte, it produces no ions or any ions in water. And no current flow. And bulb remains unlit. So that's strong, weak, and non-electrolytes. Now let's see if I can give you some examples. For the strong ones, if we have, for example, NaCl in water, that's a strong one. Here, for example, acetic acid, CH3COOH in water. That's a partial dissociation, weak electrolyte. And glucose, C6H6, or yeah, we can write glucose or sugar, CO2, let's say, for example, CO2 in water, non-electrolyte, or sugar in water. They do not produce ions. They do not conduct electricity, right? So that's 3 types of electrolytes.